Hey engineers, we're going to talk today about a Crossflow heat exchanger. So we have this Crossflow heat exchanger demo that we're going to do, and then I'm going to show you a more real life Crossflow heat exchangers. That's what we're going to aim for today. All right, so I just want to explain what we have going on here. We have a tank of warm water in the back here. It's about 51 degrees. It's being pumped into the heat exchanger, going through these coils and then coming back out into the tank. And there's a temperature gauge measuring the input temperature, so 51 degrees, and the output temperature, which is 47.7 degrees. So this is getting cooled off. There's a fan inside this unit here that's sucking air from the room. This tells us the room temperature is 22 degrees, sucking air from the room through and pushing it out this other side. And we can feel on this other side, if you put your hand here, this air is warm. It's heating up the air as it's cooling down the water flowing through the heat exchanger. And so the flow rate, right now it's reading at 1.11 liters per minute. And we could do an energy balance of this system. We could figure out what the total heat exchanging is. So the heat going is being transferred from the water to the air, and that's why it's heating up the air and cooling down the water. If I look at the temperature of the air flowing out, the air is 44 degrees Celsius as it moves out. So it's pretty warm air as it comes out of that heat exchanger. And so there's a lot of heat being added to the air. All right, so this is the exact same thing we had at that small scale model. This is in the top level, the ITL, and this is how they heat and cool the air in the ITL. This is that low pressure steam that was coming. We had high pressure steam coming from the power plant. There was a throttling valve that converted it to low pressure steam. And it's pumped in here. We have a bunch of coils just like we had downstairs, and we have air being blown across those coils to heat up that air. In the summer, we can switch that. There's chilled water being pumped into some different coils, and so we can blow, instead of blowing the air over hot coils, we can blow the air over cold coils. And so we're going to look in. We can look in here in just a second, and we'll get some video of what it looks like with the fan. But this is the same thing, and both of these have return pipes sending the water back to be re-chilled or reheated at the steam plant. I real quickly wanted to take you to the basement of the ITL and show you where the high pressure steam comes into the building. So there's a big power plant next to the Champion Center at CU, and that's where all of the steam from campus comes from. And it's piped all over campus via underground tunnels. It comes in here at high pressure steam in the orange pipe that's behind me. It's then converted via throttling valve into low pressure steam that we can use in the radiators and in the heat exchangers in the building to heat the building. There's examples all around me of constant flow devices that we've talked about, like throttling valves, and we're going to look at some pumps in just a second, but this is where most of the magic happens inside of our building. This is a pump. Water comes from the heat exchanger down through the pump and is pumped back to the energy plant to be reheated. And the reason it's set lower and then goes back up is to avoid pressure drop in the pump. But this is what a pump looks like, and I wanted to make sure you got to see it.